Good day, Algebra. For the first time, we're talking about CO14, which is our last rule of the five. And when you look at these expressions that you see here, every hand should go up in the air now. What do you notice they all have in common? Eli, parentheses. And think back to when we solved equations. When you see an equation with parentheses or an expression with parentheses in it, what are you thinking? What strategy do you need to employ? Will. The distributive property, right? And so the question was asked before we started to record, this looks pretty simple as it is here. Why mess with it, right? And the reason why is because as we get more complicated expressions, we're going to start to combine the rules together. We're going to start to get this longer stuff. Being able to simplify might allow you to either cancel things out, which does make it less, makes it simpler, or when we do end up starting to solve for the variable in these things, you've got to be able to have a strategy to get the variable by itself, which for expressions like these would involve to distribute the power. So to distribute means to give the exponents to every, I'll put everything, in parentheses. Okay? To give the exponents to everything in parentheses. And just like we did earlier in CO10 and CO11, we're going to look at what this is in expanded form first to try and understand why the rule is what it is, why the rule works. So 4n squared, what is the base of that square? What is the base of that power of 2? Paisley. Right, the 4 is included now, right? Usually coefficients are not affected by the exponent, but here it is because of those parentheses. So what we're squaring is we're actually squaring 4n times itself. It's not 4 times n, it's 4n times 4n. And again, that 4 is included as part of the base because it's in parentheses. And what is 4n times 4n equal? Well, 16n squared, okay? Or you could also write that as 4 squared n, not n to the 6, 4 squared n squared, right? If you chose not to multiply that coefficient out, 4 squared n squared or 16n squared. Either one would be considered correct, okay? The next one, that exponent of 3 on the outside of parentheses, what's being cubed? What's the base of that 3? Everything in the parentheses, right? 5xy squared. So in expanded form, we are multiplying 5xy squared times another 5xy squared times another 5xy squared. Okay? Because that whole thing is in parentheses, we are cubing that entire term. 5xy squared times itself 3 times. Now, how many 5s do we have all being multiplied together? 3 of them, right? 5, 5, and 5. We can write that as 5 cubed. Not 5 to the negative third, 5 cubed. Right? And then how many x's do we have total all being multiplied together? 3 of them, so x cubed. And how many y's do we have total all being multiplied together? 6, right? 2, 2, and 2. Nathan's already kind of making connections here. He's looking for how do we get from our original expression to our answer. His hypothesis is, so if there's an exponent on the outside, when we distribute that in, we multiply the powers. It seems to hold at least for that example, right? Let's do the last one, see if it continues to make sense. We have a fraction. A lot going on here. What's the base of that outside power of 2? What's the base of that outside power of 2? Nathan? Everything in parentheses again, right? That whole fraction is being squared. So we have 5n squared over 4t cubed times another 5n squared over 4t cubed. Right? We're multiplying something times itself, whatever that exponent is attached to. That outside power of 2 is attached to everything in parentheses. So we're literally multiplying that times itself. And let's just multiply fractions, right? We can go straight across. How many 5s do we have all multiplied together in our numerator? 2 of them. So 5 squared, right? And how many n's do we have total? 4. So 5 squared n to the 4th. Our denominator, how many 4s do we have? 2. So that gives us 4 squared. And how many t's do we have total? 6. And by putting it out in expanded form, you can see where that comes from, I hope. Right? You can understand why we have 6 t's. Because 2t cubed times another t cubed is t to the 6th. And we can draw back on our previous rules and we can see that. So now we kind of say, does Nathan's hypothesis hold true for this one too? When you distribute this exponent on the outside into the parentheses, 2 times 2 gives us 4, which is how many n's that we have total there. 2 times 3 gives us 6, which is how many t's that we have total there. Right. So it seems that for exponents, we can start to fill in the rule here, exponents are multiplied. And that would be correct. Okay, when you distribute an exponent into parentheses, exponents are multiplied. Now notice I've got 2 different kinds of bases here, coefficient base and a variable base. The reason why they're different is because now those coefficients are part of the base, right? So it's a coefficient of 4, yes, but it's also a base to our exponent of 2, right? The coefficient of 5, yes, but it's also a base to the power of 3. Here we have coefficients of 5 and 4, which are also bases to that power of 2. So adding that word base here is important for this rule because of those parentheses. And what did you notice happened with our coefficient bases? 4 to 16, or 4 squared. 5 to 5 cubed. Let me draw the line here. All right, 5 to 5 cubed. And this one became 5 to 5 squared and 4 to 4 squared. What do we do? What's the rule for distributing exponents into those coefficient bases? Nathan?
You just add the exponent?
Right. The coefficient base gets the power or takes on the exponent. Again, why it's important to understand the difference between bases and coefficients. This is not 4 times 2 to get 8n squared, right? It's not 5 times 3 to get 15 x cubed y to the 6th. Being a coefficient base, it gets the power. And we can see why. Why is it 5 cubed? Because we got 3 5s here. 5 times 5 times 5. 5 cubed. Okay? But if you're using the rule too quickly or you don't understand the difference between a coefficient and a base, you can get caught up. And then finally, what happens to the variable base? We had a variable base of n. We ended up with an n. Variable bases of x and y. We finished with bases of x and y. N and t. Finished with n and t. The variable bases, Sam? Well, they do. The exponents are multiplied. We already kind of covered that. Even this first one, it's n to the first, and 2 times 1 still equals 2, right? But what about the base itself? Izzy? Stays the same. Okay? The base itself stays the same. The exponent changes because it's multiplied, right? But the actual variable base itself doesn't change. And there you know more about exponents now than you ever have before in your life. Who feels powerful? Did you get it? But powerful exponent? You weren't laughing. I wasn't sure. All right. Okay. All right, here we go. Let's practice a few more. Write the expression in expanded form, then simplify. I advise you to simplify what you can inside the parentheses parentheses before distributing. With this rule, there's a lot going on. So for example, this last one here, what can we do inside the parentheses before we distribute? How can we make our lives just that much simpler by simplifying? Colin. Right. Right. Two bases of n there, one being a negative power. Here's where we're kind of getting a taste of what CO15 will be like, where we can do more than one thing. I can move that n to the negative third down to the denominator, combine it with my n squared, and now I've got n to the fifth in my denominator instead of n to the negative third over n squared. Why that's helpful is going to keep my numbers smaller when I distribute in this 2, and it's one less thing I have to give the 2 to, right? It's anytime you've got multiple bases. Like if I had, I think on the second page, you'll see if you've got more than one of the same base, you can always simplify before you distribute. So let's just finish this one out here. All right, we're going to distribute this 2 into the parentheses. Everything gets it. The 3 gets it. And what will that become? What's the numerator of my simplified expression going to be here? Chase? 3 squared, right? 3 to the power of 2. That coefficient base takes on the power, becomes 3 squared. I also distribute my 2 into my other coefficient base, which will make that 2 squared. And then I distribute my exponent into my variable base, which already has a power, n to the 5th, which will become n to the 10th, right? Exponents multiplied. So my simplified expression is 3 squared over 2 squared n to the 10th. If you wanted to multiply those powers out and put 9 over 4 n to the 10th, then you could. Okay? Either one would be fine. We didn't write that out in expanded form. Shame on us. We'll do it going forward. Okay? What's the other one you want to do? What other one looks particularly fun? Maddie?
15x to negative, or x to the negative 2.
Yeah, first one. So for this one, we've got that negative power there. We could move it down to create a fraction before we distribute if we wanted to. Since there's nothing else we can combine it with, it's not really going to be to our advantage. It's not going to make it simpler. So for this one, I'm just going to go ahead and distribute first. Okay, I'm going to distribute my positive 2 into my coefficient of 15. Oh, expanded form. Okay, expanded form. We've got 15x to the negative second times another 15x to the negative second, right? We're squaring everything inside of the parentheses. We are supposed to write these in expanded form first. I should follow my own directions. And so now using the rule in combination with expanded form, I see I've got this 15 times 15 here, right? I've got 2 of them, which means that my simplified expression will have a 15 squared, which we can also see with the rule because that coefficient base takes on the power, right? Then how many x's do I have total being multiplied together here? I have x to the negative second times another x to the negative second. Negative 4, right? Negative 2 plus negative 2 would give us negative 4. And we multiply when we distribute our rule, right? Positive 2 times negative 2 gives us negative 4. So both expanded form and the rule justify what we have here, right? X to the negative 4th, because negative 2 plus negative 2, when we multiply by the same base, the exponents are added. And then when we distribute, we multiply. Now, this is not in simplified form. Now I can move that negative 4 down to my denominator and get 15 squared over x to the positive 4. Had I done it before I distributed, we would have got the same answer. Doesn't really make make a difference, but there you have it. Let's go to the last one in the first row, that negative 4n cubed, that being squared. Just because we have that negative sign out in front of that 4. Okay. In expanded form, what's being squared is negative 4n cubed. That negative sign is part of the base as well, right? Negative 4n cubed times negative 4n cubed. So, how many negative 4s do I have being multiplied together? Andrea. And what is negative 4 squared? Or negative 4 times negative 4? Positive 16, right? So when I write this out, I'm either putting a positive 16 in front, or I'm putting a negative 4, but I've got to keep parentheses around it to show that my negative 4 is still part of the base. Okay? Without parentheses, it's going to be a negative 16. I need parentheses to show it will be a positive. I can see that. Negative 4 times negative 4 is going to be a positive value here. Right? And then I've got n to the 6th either way. Because when I distribute, I multiply the powers. Okay, see I've got six n's there. So there we have it. Do the next 3 on your own. I'm going to give you 3 minutes to do it because we only have 5 minutes left. Yes, Andrea? I'm going to pause the video so you can do it, and then I'll take that one for you. So work on these 3 on your own if you haven't started them already, and then we'll come back and check answers before we leave. It will be yes. Yes, it will be. All right, back to these 3 here. The answer you should come up with here, you got 3n times 3n times 3n expanded form. So 3 cubed n cubed, right? Basically just this exponent of 3 goes into each term, each part inside of the parentheses, okay? And 3 cubed n cubed. The next one, that 4 gets distributed. Writing it out in expanded form, 2x squared y cubed times 2x squared y cubed times 2x squared y cubed times 2x squared y cubed. Thank goodness for the ruler, right? We have 4 2's all being multiplied together here. So 2 to the 4th. We've got all these x's, 2, 4, 6, 8 of them, x to the 8th. And then these y's as well, 3, 6, 9, 12. Following the rule, 2 to the 4th, x to the 8th, y to the 12th. That coefficient base gets the power, the exponents are multiplied. Okay? Hold on, Paul. I'll answer every query that you have. Just let me get through this first. The last one, interest of time, I'll skip the expanded form. You should get 5 cubed, x to the 12th, over n to the 9th. And that coefficient 5 takes the power, 5 cubed. The exponents, x to the 4th, 4 times 3 is 12, and n cubed, 3 times 3 is 9. Eli? Yes, if you multiplied out the 5 cubed, it would be 125. Correct. Your homework for tomorrow is to finish the backside of the page. It's all the distribution rule. So have fun with that, children. Have fun with that. All right, that's time math. Thank you.